Since a is under the square root, what type of equation is this? Yes, what do I do to both sides? Of course. Awesome. Thank you. So the left hand side is r squared, and the right hand side is awesome. Thank you very much. And from here, a equals, that's it. Very good. Awesome. Now I would like to address, so now I'm comfortable that this is all done. So now I would like to address few problems from 1.7. 1.7 deals with linear inequalities and absolute value inequalities. Any questions from me before we move on? Are we okay? Are we okay? Good. So anything you have, stop me anytime. So I want to go back to 1.7. We did an example last time, but it was just one, and I'm not comfortable. Just one example is not good enough. Do we still need to solve linear inequalities? Do we still need to solve linear inequalities, or can we move on? Okay, very good. So you can choose all these problems, linear inequalities. I recommend between 27 and 50. You said 40, 45. And this is on page 203. 45, 45, 45. Good one. Oh, awesome. Awesome pick, because I was going to pick something like this, similar to this, because I was going to say, please don't ever be afraid of fractions. Please. So let's look at these three denominators and decide what is the least common denominator. Very good. So we will multiply everything by 18. I recommend this method, knowing that I'm multiplying fractions. I will do this. Instead of 18, I will multiply by 18 over 1. I will multiply by 18 over 1 and multiply by 18 over 1. The reason is because I will see how to simplify better, easier. It's up to you. So let's simplify and tell me what you get. You will simplify by 6. Do not multiply unless you want to distribute. If you want to distribute from the beginning, let's do that. Or just write it out first. It's up to you. So what will you tell me to write on the left-hand side? So you want parentheses then. You can say 3x minus 4. You either say 3x minus 12, or you say 3 parentheses x minus 4. Which one is it? Very good. Then I agree. Good. Now you will simplify by 9. And you will say, awesome, I agree. And then you will simplify by 18. And you will say plus, awesome. Good. Now I have to combine like terms, both sides. And then like with an equation, I move terms around. So 3x minus 12 greater than or equal to 2x plus 1. I want 2x here and I want negative 12 there. What will you tell me to do next? Right, just tell me what to write. I always start with the variable. The variable is the focus. 12 can wait.
X greater than or equal to 8 plus 5.
So x greater than or equal to?
13.
That's it. In interval notation, from 13 to the right, x in the interval, 13 comma infinity. Any questions? Let me remind you, it's on the front page of the syllabus. I am in this room every Saturday from 11 a.m. till noon. If you have any questions, if you can, if you want to, you're more than welcome.
So 11.
11 to noon in this room. Okay? Good. So absolute value equations. Inequalities, I'm sorry. Absolute value inequalities. They are of two types. This type, I'm choosing a very simple example. And this type. Of course, I don't have to have the equal symbol. It can be just less than, or it can be just greater than. Okay. So I know, as I said, we worked on one problem, but there was just an example. I think Shelby asked about this. Okay. No, I need to refresh your memory on this. Like before, a few minutes ago, what did I do here? I simplified as much as possible, and then I asked myself, what can I have here? Well, I can only have 7 because the absolute value of 7 is 7, or negative 7 because the absolute value of negative 7 is 7, right? Good. Now, this situation is somewhat similar, but not exactly the same. Okay. I'm doing the same thing now, and I'm asking myself a different question. I'm asked to find these numbers whose absolute value or distance from 0, I'm asked to find these numbers whose distance from 0 is 3 or less.
It's between -2 and 3.
That's it. That's the answer. In between. So this, I'm making a point. Don't erase it like that or cross it out. I cannot solve this. I can't touch the absolute value. Like we didn't touch it here. We didn't do anything. We only thought. How do I solve this? I don't know how to solve it. But if I am able to change it into these two, then I can solve it. But otherwise, I can't touch it. Same thing here. I don't know how to solve that. But by simply thinking, where will I find numbers whose distance from 0 is 3 or less? So then the solution is -3 less than or equal to x less than or equal to 3. Thank you, Tim. So therefore, this must be in interval notation, this. Now this one is more difficult. So let's think about this second one. I'm asking myself the same question. Okay, what am I trying to do here? Oh, I'm trying to find numbers whose distance from 0 is 3 or more. Not 3 or less, but 3 or more. So this cannot be presented nicely as a chain. It's not going to work. I have two situations here, and let me show you the real line. So I have a 0 here. I have negative infinity, infinity. Let's say this is -3. This is +3. This interval is taken by this inequality. This inequality will take everything else that is not in the first one. It will take this, and it will take this. So this inequality is more difficult because I have to write two separate inequalities. What is this inequality that I have to write? X inequality. You're right. Greater than or equal to 3. And the other inequality has to represent this. X. No. Less than or equal to 3 will include the blue. Yes. Yes. This is more difficult because it will always have the union. I can't put these two pieces together without having the union symbol in between. So I have this side, which is -infinity to -3, and this side, which is 3 to infinity. So that is the difference between the two. And now I would like you to choose anything you want, really. But those problems are between 59 and 79. 57 to, yes, yes, 51, yes. These are the problems.
Filtering, mixing, mixing.
So I would like to illustrate with a problem that has a less than and with a problem that has greater than. Please choose.
We still have to write x in, so the x in,
Yes, x in the interval this.
if we just give you that. if
I'm
you ask
fine.
that, that's correct.
I'm fine, yes. Good, so let's choose, please.
H.
Okay, I'm going to choose 78. And this is 3 minus 3/4 x in absolute value greater than 9. I have to look carefully and decide which one it is. Which one is it? Is it the one in between or is it the one outside?
Outside.
It is the outside because it's greater than. It's 9. Greater than 9. So again, I'm making a point. Don't delete or erase anything. I can't solve this unless I am able to change it into two different inequalities. What is the first inequality I have to write? No. You're giving the solutions, but I can't. This is a different expression than 3. It's not than x. It's not just plain x. 3 minus 3/4 x must be very good. Or the other one, 3 minus 3/4 x must be less than negative 9. Now this I can solve. I'm going to subtract 3 first. Negative 3/4 x greater than 6. How do I continue? Negative 3/4 x greater than 6. How do I solve this inequality? I'm back to linear inequalities. What do I have to get rid of? Negative 3/4. How do I get rid of negative 3/4? What do I have to do to both sides? Multiply both sides by? But negative. Yes. So we multiply this side by negative 4/3, and we multiply this side by negative 4/3. What do we get on the left? Awesome. What do we get on the right? I recommend simplify by 3 first. Always simplify before you multiply. Good. But now I have to think for a moment.
Switch the.
Yes, because I multiplied both sides by a negative number from greater than to. Very good. Awesome. I repeat the process for the second inequality. I subtract 3 from both sides. I get negative 3/4 x less than negative 12. Again, what am I trying to get rid of? Negative 3/4. I agree. So what do I multiply both sides by? Awesome. Both sides. What do I get on the left? Exactly what I want. Of course. What do I get on the right? Always simplify before you multiply. 3 divided by 3, 12 divided by 3. Yes, I have to switch the equality symbol. And what do I get? Very good. Now, can anyone give me the solution with the union in between? Awesome. Union. Perfect. Well done. Any questions? Any questions for me?
I have a question.
Yes.
Why did you not use the square bracket in this
expression?
Because there is no equal symbol.
Okay.
Yes. When I have the equal symbol, I use the bracket. When I don't have, I use the parenthesis. It only means that that end point is not included. Right. If it is included, I have to use the bracket. Perfect question. Let's also look at the other one, like 94. 2 minus x over 2 minus 1 less than or equal to 1. What do I have to do first? Yes, I have to add 1. Yes, it's not cleaned up yet. So 2 minus x over 2 in absolute value less than or equal to 2. Now remember, I can't solve this. I can't touch it. I cannot do anything to it. So I'm only asking myself, is it in between or is it the outside? It's the in between. So then this goes away and I replace it with
Yes.
you just said in between. So when you said in between, that's what I'm writing. Okay, I guess it's not clear. This is what we did here. You said in between, right? So this quantity must be between negative 3 and 3.
Less sign for the division.
So less than or equal to?
Zero.
Very good. So this inequality requires that this quantity is between negative 2 and 2. Right? Perfect. How do I solve this? I have to get rid of the weakest link first. The weakest link is 2. So negative 2, negative 2, negative 2. The left-hand side is? The middle part is? We can, yes, change it. And the right-hand side is? Perfect. What am I trying to get rid of next? And that's the last step. Yes, multiply both sides by negative 2. When I multiply this by negative 2, what do I get? Good. When I multiply this by negative 2, what do I get? Perfect. When I multiply this by negative 2, what do I get? Okay, now we have to think. Yes, it won't make any sense to have 8 less than or equal to x less than or equal to 0, right? So now I have to read from this side. Can anyone read from this side for us? 0 is? No, not, it cannot be greater than or less. Yes, 2. And?
Less than or equal to.
So that's why the solution is 0 to 8. Two things I want to make sure I'm not going to see in your test, work, or anything. Please don't ever show something like this. Never. And please don't ever show something like this. These do not make any sense. If you need to make yourself a note, please make yourself a note. These two have no meaning. Okay, now I feel that everything in chapter 1 is completed. Please look at some word problems, come back and say, I want to see this, I want to see that. Okay, so this is done. I have to admit, 1 or 2 examples are not enough. That's why I want you to work at home and then come back with questions. Please. Okay. Just a couple of minutes, let's say, about your classwork today. It's going to take 2 minutes at the most, really. So allow me a few more minutes. So one thing that in 2.1 that we did not get to talk about is what it's called symmetry. Not all functions are symmetric, but it's so nice when they are symmetric. And there are 2 types of symmetry. So 2 types. One is called even. What do you think? Wild guess is the other one called? Of course. So let me give you an example. Here's the graph of a function. We know what this function is. You don't have to tell me, or we don't have to write it. And let's look at this function and say, I'm going to choose a value x. I am going to draw a vertical line where it hits the graph, and I am going to read this y value. Maybe I should draw a bigger graph. Can you see? Okay. So can anyone give us this height? Or in other words, I'm asking you for the coordinates of this point. If the x-coordinate is x, and this is the function f of x, what will be the y-coordinate? You can say y, which is fine, it's correct. But then I'm going to ask you, is there another way of writing y? Y is also replaced by, thank you. Stay with me, please. Let's say I'm going to the other side, and I'm going to exactly symmetrically on the other side. I'm going to say this is negative x. I don't want it to be influenced by any of that. So I'm going to draw the same thing, a vertical line, and then from there I'm going to find the y-coordinate. Can anyone give us the coordinates of this point? Yes, x-coordinate is negative x. What will be the y-coordinate? Awesome. Thank you. That's awesome. Thank you. So indeed, f of negative x. Now, since I picked x on one side, and negative x on one side, and I went up till the function, and then I drew f of x and f of negative x, what is the relationship according to the graph? What is the relationship between f of x and f of negative x? They are look at the graph. They are okay. No, my graph is not good enough, obviously. Exactly. Of course, but only one student saw it, so my graph is not good enough. My graph wasn't good. Now is it better? So what is the relationship between f of x and f of negative x? They're equal. So f of negative x is identical with f of x. If that happens for a function, the function is even. And it means it's symmetric with respect to
Y.
It's symmetric with respect to which axis? There are two axes. I can say this. Yes, very good. So symmetric with respect to WRT, with respect to the y-axis. Perfect. That is called an even function, and its graph will be symmetric with respect to the y-axis. Very good. Let's look at the other option. And then I'll stop. Here's the other option. I'm going to draw a bigger graph so we can see it better. Sorry about that. There will not be a function. So if you have something like this, that would not be a function. So with respect to the x-axis, it's an equation. It's possible, but not a function. Okay, so let's look at this. So now I'm going to pick, of course, my x on this side and my negative x on the other side. And I'm going to get what here again? Say it again. You said? Yes. Okay, I would have to agree. And then I'm getting here. Don't look at that. And tell me what you get over there. Awesome. Now, please tell me from the graph, what do you expect the relationship between f of negative x and f of x to be? You cannot say equal, right? Opposites. Awesome. Very good. So f of negative x is the opposite of f of x. If that happens, the function is odd, which means its graph will be symmetric with respect to, don't say anything, I want to show you 3 points here. 1, 2, 3. If I draw a line through these 3 points, this piece is equal to that piece. So the graph of an odd function is symmetric. WRT with respect to the origin. Indeed. With respect to the origin. Any questions for me? Any questions? Okay, open notebook, but not your colleagues. Approximate, show on the graph, and I will be happy. Okay? There are a couple of questions. As I said, you should take a minute, but do not rush. I don't want you to rush. At any point in time, approximate if you need to. And if you show me on the graph, I'm fine.